we need to remember, just using our language before we approach it, is knowing that my next term is equal to my previous term plus or minus a rate of change that is going to be constant. So for example, in my XY chart here, I can see that as my X increases by 1, my Y's are increasing by 2. That means that my recursive rule for this will be f of x. My next term will be the previous term plus 2. And I also need to include my f of 1, which I brought down here. My f of 1 is equal to 5. You need to have both of those components for your recursive formula. In the recursive quadratic, again, we're thinking about my next term is equal to my previous term plus, and that will be a linear difference. So my next term is equal to my previous term plus a whole equation, like I have written here. Now this one I've solved for you. We want to be focusing on the second difference. It tells us what our multiplier is. Our second difference, I multiply by n, and then I figure out my formula. And how do I get 2n to yield a 0? Sorry, 2n to yield this difference. I need to subtract 1. If I multiply 2 times 1 and subtract 1, I get 1. 2 times 4 minus, 2 times 2 is 4 minus 1. I get the difference of 3. That gives me my first difference here, which is my linear difference. So I take my previous term, my 0, and I add 2n minus 1. So for example, my f of 2 is my previous term, which was 1, plus 2n. This was making clearer this part of it. So I need to figure out the linear difference for f of 2 was 2n plus or minus an amount, and I figured out that that was 1. So I used my first difference here to find my linear piece to the quadratic equation. And then I plug that into my previous term. So that would be my f of n equals my f of n minus 1, which is my previous term, plus my linear difference, which was 2n minus 1. You will also need to know for this test the difference between linear and quadratic presentations. In a linear form, our visual might be a set of dots. It might be a set of blocks, as we saw in our logos that we were studying in Module 6. This would be an example where I have sets of dots. My first set of dots is 3. My second set of dots has 6. My third set of dots has 12. I would write my table like this: x, y, 1, 2, 3. Those are my figure numbers, or my set numbers. And then I would record the number of dots I have over here: 3, 6, 12. I would need to look at my pattern. What is happening here? Every time I'm being multiplied, the x is being multiplied by 2. My previous term is being multiplied by 2, and that's how I'm getting my next set of y value. My first difference is constant, and you can see here This first difference is a constant of being multiplied by 2. It could also be added, subtracted, or divided. So when I'm looking at my recursive formula for that, I'm thinking in my head, using my words, my next term is equal to the previous term plus minus times divided by some set amount. These amounts could be addition, subtraction, multiplication, or division. And I've written out examples for you here. In a quadratic presentation, we would definitely see a parabola. In some of our examples, we've only seen half of a parabola. In its visual presentation, we would have a set of dots possibly, or blocks, that would increase in a quadratic pattern. This set of dots has 4, this has 9, and this has 16. If I'm making my XY table from there, I'm going to record my figure numbers in my X column and my output in my Y column. I have 4, 9, and 16. My pattern is not increasing at a constant rate. My first difference was 5, 7, which does not give me a constant first difference, but it does give me a constant second difference. I'm going to rewrite this out here so we can see 1, 2, and 3. I have 4, 9, and 16. I have a difference here of 5 and a difference here of 7. In my second difference, I have 2, and if I went farther here, then I could see this would also increase by 2, so that would be a 9. And this would give me, let's see, 25. We saw some examples that were just like this. This will require 2 math operations. My recursive equation will need to include my previous term plus a linear equation to determine what my next term is going to be. In the explicit form, the quadratic equation would be written y equals ax squared plus bx plus c, and it's much easier to figure out what a, b, and c are going to be equal to, because I'm going to take my a divided by 2. So I'm going to take my second difference, divide it by 2. That gives me a. So up here, if I'm looking at my second difference, is 2. 2 over 2, a would equal 1. B, I don't know. I need to plug in an xy coordinate to find that one. My c is the y-intercept, which is this constant term or 0 term. And that is where my y-intercept is, so then I would need to go backwards up here. So if I know that this is decreasing, as that in this direction it's increasing, but this way it would be decreasing, I would subtract 2, which would give me a 3 here instead of a 5. And then that number would be a 1. So I would have c equals 1. Then I would plug in one of my coordinates. It doesn't matter which one I plug in. And then I could find b from there. The last concept you'll need to know for this test is finding the rate of change at an interval. You will be asked to find the rate of change at a specific time or place. That is what an interval is. Do you remember with the tortoise and the hare, the conversation we had? So the formula for this is f of b minus f of a, which are y values, over b minus a at the interval ab. So when you are asked this question, you will take your intervals, these are x values, and you will plug them into the equation. So if a is -2, I plug it in to this equation. This is the equation they gave me, f of x equals 2x minus 3, and I find the value. Now I know that f of a is -7, a is -2. Then I take this b value and I plug it in, and I get f of b, 2b minus 3, or f of 3 is 2 times 3 minus 3, which gives me 6 minus 3, which is 3, and that is my f of b. Then I take my f of b and my f of a, and I plug it into this formula up here. And I wind up with 3 minus a -7, which is the same as 3 plus 7 is 10, and 3 minus a -2, which is the same as 3 plus 2 is equal to 5, which is 2/1. So the rate of change at interval -2, 3 is 2/1, or 2. Those are the concepts you will need to know for your test tomorrow.